Good evening and welcome everyone. This is Obi-Wan Pez for N Simplex Pachinko. We are here tonight trying something different, so we'll see how it goes. So I am kind of interested. Can I do something here? Get the stream manager up. Hmm. Haha, let's try it. Okay, so we are going to set up a vote. I mean, there's probably like only 2 people here anyway, but you know, we'll see how it goes. Let's see. All right, let's try this. I mean, almost missed is a very subjective thing because I put 5 minutes on it. So okay. Is that any better? Vote and run, man. Alright, that's fine, Megalomorph. See you later. Sorry you can't stick around, but hopefully we'll do something interesting. Might be able to catch it later. Alright, sorry about that. Just checking audio. Alright, so in case anybody is new here, welcome in. I am Obi-Wan Pez. This is N-Simplex Pachinko. We're actually going to start the stream now, so, you know, it's cool. Okay, so, got one vote, which I suspect is Megalomorph, for mathematical thinking. So this is the thing we were still working on from last time. Let's see. I'm gonna bump out then and go back to this one. Whee. All right, so we were talking about functions. All right. So we were, you know, one of these days I'll actually like plug in the equipment before the stream starts. That's always fun. But then again, if I ever did that, we wouldn't have these fun little interludes. Okay. Okay, there we go. So, I won't introduce myself again. We started the stream tonight around 18 minutes. Cool. Okay, so we were talking earlier about looking at element-wise mapping from A to B, talking about one set onto another, and that allows us to look at domain and range. I should not talk about onto. That's something else. So for instance, for f of x equals x squared, our domain is going to be the all real numbers. Our range is not technically here. Cool. Our target is going to be all real numbers, whereas the image, or this is what I commonly refer to as range, is y is any number greater than or equal to 0. So that kind of restricts our values when we get there. Okay, so they talk a little bit about schematic representations. This is kind of our standard. That's not what I wanted. Okay, just undo that one. Oh, cool. Somewhere where you can actually see it. So this allows us to take the domain, which we call A, and using the mapping F, this is going to take our image versus our target. All values in A, which are part of the actual domain of this thing, are going to map over to our image on the other side for B. And we also have some unbounded or unmapped elements of B, which are going to be in the target but not in the image. So in the case of our quadratics, again, we had the image, y is greater than or equal to 0, so all negative numbers were going to be in the target but not in the image. Okay. So as always, image is going to be a subset of the target. Maybe an improper subset, so it can be exactly equal to in the case of linear functions, right? We've got real numbers to real numbers. The target and the image are going to be the same thing. think I got some... Yeah, it's some tapping in the song that sounds like somebody's knocking at the door here. It's crazy. Alright, so f as a function is going to map a to b. So f is going to be defined on A maps A into B. Alright, so for all x belonging to A, f of x will be member of B. Well, it's also going to be an image, so okay, so this also goes on to define coordinate pairs, so we can say that we've got f at A is going to be some sort of, again, A belonging to big A, f of A technically belonging to B, but again, do we want to distinguish that it's specifically inside of the image? I mean, like I would. Okay, so this says then we're allowed to describe formulas. Now, I have a little bit of a bias against the word formula itself, just because I think everybody is desperately trying to use formula to represent some sort of algebraic representation of a particular application, and not using it in a very general sense, or without really necessarily knowing what the definition of formula means. I think maybe I didn't either. So functions describe formulas, describe... Me fail English. That's impossible. Vuitton Vector. Good evening and welcome. I'm Obi-Wan Pez. This is N-Simplex Pachinko. I hope you will find that this is a good home for all things mathematical. If you have any questions, please pop them in the chat, and if you just want to lurk and hang out, that's fine too. So our squaring function that we had up above right? S of x being x squared was going to define S mapping reals to reals. Yeah. Right, we could also come up with all sorts of other stuff. So there's like this one gives a couple of examples. So what is squaring? Well, squaring is made up of multiplication. So this is technically like x times x. Well, what's multiplication? Multiplication of two objects is going to be given by the formula x times y. And then what's multiplication? Well, that's really x plus x plus x plus dot 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 plus x for a total of y times. Well, what's addition? So the addition of two numbers is going to be, again, x and y as both inputs. It's going to give us like x plus y, adding those things together. In all these cases, our inputs here, so a and m, are both going to be defined as taking two inputs and then outputting one real number. So here this was all of our x's and all of our y's. Oftentimes this is rewritten. Instead of r by r, it's just r2 mapped onto r. So again, we get all of our inputs and output. In this case, there's two inputs, one output. Okay, so then it's actually reversed. So functions can be described as formulas. Functions can be described as values. So in this case, we've done stuff like have a table of values. So some XY table like this is going to allow us to have some sort of pattern. So like -3, 0, 3, 6, and I don't know, let's try 12, 5, 0, -3. Yeah, that's good enough. So this particular function here is going to be mapping x, a real number, into some y values, another real number. So if y is like g of x, a function, then this means that we're going to get g of -3 is going to be 12. G of 0 is going to be 5. G of 3 is going to be 0. And G of 6 is going to be -3. These are only defined for these values and none else. Hey, Bertram. What's very confusing? So for this is going to be, I've probably mentioned this before, but this is going to be discretized. You missed the vote. Functions? Hope not harassing you too bad about it. So like table of values? These? Function notation? Or were you talking about the stuff up here? Yeah, sorry, I don't think I follow. Oh. Oh, mapping. Yeah, so basically we're just trying to show like what set is going to be what set is going to be mapped onto what other set when you're talking about functions. I remember it's I forgot. I hate it when that happens. So I drew something while you're out. So we said like here we have A, which is going to be our input. Is going to be our input set. So this is going to be all the values which could possibly go into the function, like our domain. Alright, and then here we have our target, which is all generally like what's the larger set that we're looking at? What kinds of numbers are going to come out of this thing? And then our image is the actual values that actually come out. So f of x equals y is just the like function notation. I'm not saying f of x is a function. I mean, f of x is a function of x, so it can't be y, like, by itself. But I'm just saying that y is equal to some function of x. So in the case of y equals g of x down here, right? Yeah, I'm not entirely clear on the whole onto thing, just because I did not. Well, okay. I haven't taken that class in like, I don't know, 20 some odd years. It's probably been about 12 since I took my master's, and I did have real analysis in there, so I did do some of that in there. But again, it's been a long time. Amogus forever. Hello. How's it going? Welcome back. So, yeah. So like the whole onto and what its relationship is in terms of like subsets and all that. I could. I'm sure I'm going to get into that here eventually. I'm sure it's in the back. Yeah, one-to-one and onto. Oh, yeah. So one-to-one is actually not that bad. I don't typically use the exact same subscript because that gets a little, or I don't use the same variable because that gets weird. So I will insist with my students that, let's come back to this. Hang on. Format background, go blue. So I'll insist with my students, like if you're going to do something, y equals, I don't know, 4x minus 7, right? We know that this is going to be a one-to-one function. So the test for it, especially with algebraic stuff, is we're going to say that if so if f at some value a is equal to f at some value b, and f is one-to-one, then it must be true that a is equal to b. So, one-to-one is a little bit easier. If you're just looking at the algebra for it, one of the ways of saying this is there any way for this equation to lose information? Now, the most basic way for an equation to lose information would be like a square. So, y equals 3x squared minus 2. Right? In here, if we plugged in two different x values, we should, if it's one-to-one, we should always get a new value. But since this is going to be just x squared, we know that this is possible to say, okay, well, if x equals -1 and +1, wait a minute, just y equals 0. If y equals 0, we get 0 equals 3x squared minus 2. So that's 2 equals 3x squared. So it's 2/3 equals x squared. Which then, when we take the square root of this stuff, we get that the square root of 2/3 is equal to the absolute value of x. And so with this, we know that x is going to be either plus or minus the square root of 2/3. So because of that, we can say, oh look, there are two different x values that get us one y value. So this is a 2-to-1 function. The only place where it's not 2-to-1 is at x equals 0, when it's at the vertex. But overall, this function is a 2-to-1 function. I suppose it may not meet the strict definition because it does have one place where it can have 1-to-1. But again, that's only at one single point. Whereas the equation y equals 4x minus 7, we know that this is a linear function. And for every y value that we pick, we're only ever going to get one x value to match it. So here we can prove by counterexample that y equals 3x squared minus 2 is not 1-to-1. That was gross. Okay. Right. If you want to show that something is not something else, like does not hold a specific property, it's super easy. Right? You just say, here's a counterexample. But if you want to prove that it is one-to-one, you can't just say, at 0 it's one-to-one, because again, you have to prove that it's one-to-one for all values in its entire domain. So how do you do that? Well, again, if f of a equals f of b, so you were probably doing it from here and said, okay, y1 equals y2, so what happens with our x1 and x2? So y1 is equal to 4x1 minus 7, which is equal to y2, which is 4x2 minus 7. No, you don't prove that y equals x. That's a specific line, right? One specific line. You have to prove for all values of y, if two different y values, sorry, no, if we have two y values that are equal to each other, right, in points, so x1, y1, and x2, y2. If the y values are the same, if the two y values are the same, then you have to prove that the two x values are the same. Otherwise, it's a 2-to-1 function like that one over there. So here, we just basically unravel the function, which for a linear function or a bunch of those, it's super easy. You just, okay, add 7 to both sides. Therefore, 4x1 equals 4x2. Divide by 4. And therefore, x1 equals x2. So, for any x value in the entire domain of this particular function, we're going to get a 1-to-1 function. There is only one particular y value for every single x value to be a function, and there's also only one particular x value for every given y value. 1-to-1. So f of x, I defined f of x to be y. It wasn't going to be proven. So again, f at any particular value is going to be the output of that particular function, which generally we prefer it to be x's and y's inputs, outputs. And so because they are that way, sorry, inputs, outputs. There we go. I'm backwards. This is always fun. I did something like that in front of my class today. I was just like, and I'm facing you, so that's backwards. Cool. Mirroring is hard. So in this particular case, we just said, all right, our x's are going to be our inputs, our y's are going to be our outputs. If we have two outputs that are the same, their inputs must also be identical. Otherwise, it is not 1-to-1. So in terms of the word onto, oh boy, this is skipping a few pages here. Yep, surjective and injective, all that good stuff. Yep. And really, that's a better word to use for this whole function and 1-to-1 thing. So So it should also be onto, but I forget exactly what the entire definition of onto is because, again, I was never very good at this particular section. Alright. Yeah. He like basically makes a very short mention of the word onto, but doesn't actually describe it. So, math. Nope. Math. Okay. So onto is when the entire okay, let's go like this. We're going to redraw the image that we had last time here. um, all right, our function f looks like this, and A is going to be mapped onto B if, or F will, F maps A onto B if the image in B is going to be equal to B, or the target. So, in other words, for all, I guess we could do Y, but for all lowercase b in B, there exists some A in A such that f of A equals B. So for all B in big B, which again, big B is the entire target, there exists some A in A such that f of A maps onto B. And again, the image is the target. I had a feeling it was something similar to that. I just didn't want to like start spouting it off and then be wrong. Yeah. So anyway, I don't typically use x1 and x2 because that just gets kind of needlessly confusing. So rather than do that, I will use a and b specifically and define it and say, okay, well, let f of x be equal to 4x minus 7, and then I'll say for some f at a, there exists some f at b, which is equal, and again, this is 4a minus 7 equals 4b minus 7, add 7 to both sides. 4a equals 4b, divide by 4 each side, and therefore a equals b. So it's all the same stuff. It's just a matter of saying, like, I'm going to use the actual definition, which uses F's, and then A and B are different letters entirely, so it just looks nicer to me. Now, maybe somebody who wants a little more mathematical rigor can say, okay, I like the subscripts better. That's perfectly fine. Doesn't bother me any. If somebody's like, you're wrong if you do it this way, then, you know, I don't really subscribe to that sort of, I don't know, superiority. It's not my thing. Okay. So. There we go. Christmas stocking. All right, anyway. So we can describe our formula, or describe our functions as formulas. We can describe them as values. And then we can also describe them in words. So like O of n is the set of all odd numbers indexed by their order. Nah, I don't want to. Indexed by their position from least to greatest. Right, so O is going to be equal to 1, 3, 5, 7, 9, etc., where n is going to be equal to 1, 2, 3, 4, 5. Right, that's an O, not 0, so go with that. All right. Then we also want to talk about whether or not a function is well defined. So So each element of A, our inputs are going to be assigned to exactly one element of B. So it's a little bit like being a function, but it's also meaning that A just can't be like real numbers when you're talking about square roots. So if you're saying that like f is going to map A to B and f of x is square root of x, right, then here your A is going to have to be restricted. It can't just be real numbers to real. So real to real is not well defined. For all A in A, A is going to be equal to, no, A, little a. A is going to be greater than or equal to 0. So in this particular case, right, A being greater than 0, that set A is going to be defined as like real numbers. It's not really positive though because it includes 0. So A equals all values A such that A is greater than or equal to 0. Then this is going to mean that A mapped onto B is well defined. Okay, this was also saying that if we choose our g of x to be like the absolute value of x, this is actually piecewise defined. And so this gets a little iffy in terms of, like, is it well defined? Well, it doesn't get iffy, but it looks like it might have a problem. So it's going to be defined as just the value x whenever x is greater than or equal to 0. And it's going to be negative x when x is less than or equal to 0. Sometimes people complain about this and say, well, you can't have it be both less than and greater than 0 at the same time. But what's going to happen here is that, well, these values are exactly the same. So since 0 equals negative 0, then absolute value of x is going to be well defined on all real numbers. So anytime that there's some sort of piecewise discontinuity, where you might have, or rather, where you might have a piecewise discontinuity, you got to check to see if those values line up. If they do actually meet at some sort of cusp or smooth, however that's going to work, then you will end up with a well-defined function. But if you even separate them a little bit, that's going to be not well-defined at that particular point, provided that it's going to call, again, to different rules at the same point. That being said, of course, we could also just let it be a piecewise discontinuity, like the floor function. Right, the least integer function is going to say we want greatest. The greatest integer function is going to look for the greatest integer of the number x, which is less than or equal to x. So it's in this way that we have this function that goes like this. So it looks something like that. This is going to be well defined at all of those individual points. Okay, so f is going to be real valued if the image is going to be a subset of the reals. So we can't have any complex values that are not real. They're going to only be real numbers. Okay. So first of all, we have to let or remind ourselves that polynomials are going to be real valued, so they're always going to have real outputs. You can find something that looks like a polynomial and does have complex outputs, or complex non-real outputs, but it won't specifically be a polynomial. Or maybe you can call it that. I don't know, but the book is insisting that that's not a thing. Okay, so it's going to take our function, it's going to map A onto B, A into B, sorry. It's also going to map reals into reals. And f is defined as a n x to the n, a sub n x to the n, plus a sub n minus 1, x to the n minus 1, plus etc. going down, all the way to a sub 1 x to the first, plus a sub 0. Okay, and in this particular case, it's called the degree. Degrees are going to be greater than or equal to 1, generally speaking. Yeah, I guess you can call it degree 0 still. That's fine. Okay, n is going to be the degree where the term that has the largest exponent n also has coefficient such that a sub n is not equal to 0. Just that has coefficient such that a sub n is not equal to 0. All right, and if all a sub k equals 0, there's no polynomial. So we're just not even going to entertain the idea that literally everything is 0, because that would just be not only a constant function, but it is the x-axis, I guess, if you're graphing it. You're not going to get anything out of that particular setup. Alright, got rules for multivariate polynomials. So you can't get stuff like f of x comma y comma z. So if f of x, y, z is going to be equal to x squared plus y squared plus z squared minus 2x plus 2y minus 2z, then this is going to be a second degree polynomial in 3 variables. No, that's not right. Whew. So this is going to be a polynomial of second degree in 3 variables. So x, y, and z are all going to be input variables. That's what we're going to care about there. Monomial in all these variables is an expression c times x sub 1 a sub 1 to the a sub 1 plus, oh no, multiplied. Aha, I see now. Okay. Hey, Megalomorph. Go for it. Might prove to be interesting. So a monomial probably done something similar. Yeah, maybe. Hang on. Let's see. Is just a regular class, or is this, I'm sorry, is this, like, evaluating limits and all that, or is this, up to L'Hopital's rule yet in this particular class? Alright, monomial is going to be some constant times your first variable, x sub 1, raised to some power past. Okay. Times x2 raised to the a2 power times x3 to the a3 power times etc. Sub n minus 1? Yeah, that's fine. A sub n minus 1 times x sub n to the n. Nope. To the a sub n. Where c is a constant. Subscript n is going to be like the nth variable going across, and exponents a sub n are going to be greater than or equal to 0. And a sub n belong to integers. So we come back out. There we go. Alright, let's take the limit as n goes to infinity of 1 over n log of n factorial over n to the n. I guess. Gotcha. Okay. So with this, we need to know whether the tower function or the exponential go to infinity fastest. So you said use Stirling's approximation, which is going to be... Yeah, I guess we can use the approximation that's either one, right? It'll all more or less work itself out here. So n factorial is approximately equal to root 2 pi n times n to the n over e to the n. Fine. I mean, to be fair, I would probably have a table somewhere that gives me the hierarchy of functions, and I'd just go with that. Okay. So if we look at this in terms of, let's see, Calc 2, we did ratio and root tests. Eh. Yeah, but that's linear and that's a log, so. So if we do like... Okay. If we do ratio... Alright, let's see. Okay. So if... man. Okay. Sure, why not? Let's try it. It's probably not the right way, but we'll give it a shot. No, that's N. Man. Now, granted, this is usually a test for the limit when we're trying to add the particular values up. So this isn't really what we're doing, but at the same time, if we can prove that the series is convergent, then this individual thing has to go to 0. Probably won't work, but, you know, worth a shot. So here, this is going to be, take the limit, n goes to infinity. This is going to be multiplied by n over n plus 1. It's going to be n log, yeah, this probably isn't going to work just because of the... Was that George Burns film? Yeah, that's not going to work because we've got ratio of logs, which is going to make us do potentially power. That's not going to... The only way to compare them would be... Okay, let's see. What else have we done? I mean, you could do L'Hopital's. It's kind of inconvenient, and especially since, right, you're gonna have to take the derivative of. You have to take the derivative of an factorial. That doesn't. Well, we don't study it at our school. Doesn't mean it doesn't exist. It's gonna be fun. Okay. All right. Gamma functions. My students keep asking about that. They're like, what? So what exactly? I'm like, no. Alright, 1 over n times. I could do it this way. Do log of n factorial. Oh. Oh, that's evil. Really? Log of n to the n. Over n times. This is going to be interesting because that's an infinite series. Like, it's not infinite. It's a finite series of log of I. I goes from 1 to n. Oh no, I mean, I totally see sort of where this is going. Alright, minus, this is n log n. Okay, that could work. So here, this is... Okay. All right. It's not a geometric series and it's not an arithmetic series, so that's going to be just kind of fun and messed up, but there's only one of these. So, wait, hang on. Well, if I do it out, right? Or at least some of it. So, log of 1 is just going to be a 0, but we'll hold on to that just in case we want it. Plus log of 2 plus log of 3 plus etc. Okay. Okay. Maybe. If it's something I'm about to do, probably not. Very light hint if you want to. Something that maybe plus 1 over n minus n over n log n. So that's taking out so 1 over n is factored out. Log of 1 over n mean like that would be a negative, but that would be, whole thing would be negative then, right? No. Oh, okay. So then that would end up being minus n minus the log of n to every single term. Because it's this? Yeah, okay. No. Okay. So we could, if we wanted to, get rid of those last terms or keep it, depending on what we feel like. Of 1 over n times, here again, this is log 1 over n You decide, yeah, you say keep it. I mean, so we could have written this all the way from the beginning. It's fine. It's fine. Just who thinks of it, right? So realistically. Okay, so that's interesting. As n goes to infinity, each of these things goes to negative infinity. Okay, so this is going to go to infinity. Sorry, the n is going to go to infinity, which makes the fraction go to 0. And then this here is going to go to 0. So, right, this value is going to go to negative infinity. Sounds good, two curves. That's okay. You can also throw that in chat if you feel like it. We're kind of finishing up-ish on this question, so it'd be good to have one on standby. So this is indeterminate. So then we should be able to use L'Hopital's rule. Says that limit as n goes to infinity is going to be equal to... Alright, fair enough. Negative 1 over n squared. Oh, no, because we're doing derivative of the bottom. Right. If we can do L'Hopital's. 1. And derivative of the top. Alright, that's going to be a little challenging, I guess. 1 over n times the derivative of the inside, which is going to be negative 1 over n squared, plus derivative of the log of 2 over n. It's going to be, nope, 1 over 2 over n. Times a negative 2 over n squared. Right? This should be right. Plus, so this one is going to get 1 over n minus 1 over n. Times the derivative of this thing, which is not as nice as I want. The n of this thing is going to be derivative of that is just n to the negative first plus n minus 1 times n to the negative second, make that a negative out front. Okay. So it's not a continuous function, so therefore you can't do it. Oops. That's not what I wanted. Second syllable. Do we just use the distribution and then the power rule for it? Take the n. Is that nope to both of us? I mean, I do like that particular phrase there, but have a feeling that was made up. Just saying. Right, because this would be, again, going to 0, so then log of 0 raised to the 0 is indeterminate form. So that doesn't help either. Okay. Alright, toss it out there. Let's see what happens. Yeah, okay. Not entirely. Is 1 over n then going to be our... No, not really. Okay. I was thinking if 1 over n is like the delta x, but... okay. It's probably a terrible idea, but nonetheless. Alright, so all the terms are just off by an exact value, right? So this is going to be infinity of that goes from 1 to n. Is this where we want to be, or am I going backwards? So yeah, because now I'm mixing variables, so that's probably not a good idea. Well, it's an integral, but I just want to get my terms correct. Oh, right. Okay. Yeah, those are just x sub i's on the inside. Never mind. And our 1 over x is all just delta x. Okay. Technically sub I, but again, they're all the same, so that's fine. So integral of log of x dx. Going from, we didn't say. But it finite value then. Goodness. Oh, goodness. Right. So integral of a natural log is integration by parts. So that is x minus 1 times the natural log of x. Yeah. Oh, whoops. Yeah, backwards. Getting me to not write natural log this whole time. Unless you meant it as common log, which I assume you did not, but I'm guessing it also doesn't matter. It's going to just be off by a factor at this point. Let's see. Boo. You know perfectly well what I meant. All right. I'm going to be right back. So, guess that's true. All right. So, I'm going to cycle out water and definitely need a refill on that one. And I will be back in like 5 minutes or so. We'll see how that goes. And in the meantime, two curbs. If you want to place that question in the chat, I will be back and see it when I get back here. So, see you in a few minutes. Thanks for hanging out, and just, yeah, 5 minutes or so. Schleffly ortho schemes, huh? I am not at all familiar with the type. Aha. Okay. So type of simplex defined by a sequence of edges that are mutually orthogonal. I mean, who said because x wasn't defined when we started this whole thing? This is a dummy variable. Zero to... Oh, okay. Yeah. Now that makes sense. I like your... I like the cut of your jib. I see. Yeah, we've been doing improper integrals this week in Calc 2. That's always fun. Like, what? Why are you doing this to me? I was like, look, just hang on until next Thursday, because that's when I start differential equations, which is like my subject. No. That's not that at all. Jeez. So this is going to be natural log a over 1 over 1 over a. I think is probably the easiest way to do that one. Alright, so then that's going to be 1 over a over negative 1 over a squared. No, okay. Limit a goes to 0. We multiply both top and bottom by a squared. And we end up with a over negative 1. Since a is going to 0, this whole thing's going to 0. And we should just get negative 1. Yeah? Alright, cool. Woo! We did it. Yeah, I liked that progression of jokes that started with the pirates. Because back when I first started, it was R. What's your favorite? What's a pirate's favorite letter? R. And then, like, probably within a month of hearing that one, somebody came up with or heard from somewhere, which came to us. No, 'tis the sea. It's only cheating if you don't know about it. Alright, so if we look at the Schlefly stuff, again, I'm not really sure about it, but yeah. So, dimension D hypercube, how does that partition? Right. Mm-hmm. Midpoint of the longest edge is the center of a circumscribed sphere. Oh, good. Well, this is certainly going to be way above my head. It's nice. It's funny, both Bolyai and Lobachevsky are both coming up in this wiki article, like multiple times. So the one for the Schleffly orthoscheme and the one for the convex hull. No, not convex hulls. Um, convex polytope and scissor congruence. It's just amazing that, everywhere I turn, these two guys are showing up. That's interesting. Okay, let's try this. You getting it? It's like I can hear it on my phone when I turn it up. So was that like ridiculous or? Yeah, I turned it back down because I was afraid that I was blasting everybody's eardrums. So like how is it compared to my voice, I guess, is the other thing. I guess, I don't know. I just don't want to turn it up that high. Okay. Okay. Yeah. I know I've had the other problem of my microphone was way too quiet for everything, so I ended up using the boost in like the advanced properties somewhere and popped it up. I pushed the microphone to 5, like +5, whereas everything else is usually minus something. Alright, so let me turn... Ooh. No, that'll be alright. Never mind. Hang on. Can I do this just for me? I think I can do that just for me. That probably didn't change anything for you. All my audio levels are just so messed up now. It's like I have no idea anymore. Hashtag not sponsored. This is the Beer Farm limited edition Snickerdoodle Cream Ale. It's very cinnamony. All right. Anybody else want to see or talk about anything? Because Sorry, two curbs. My spouse, her father, one time when she was like, I don't know, 5 or something like that, was like, oh, no, you wouldn't like these. And she was like, oh, okay. And like believed him for years. And she was like, I don't know, probably 8 or 9, when her mom's like, he said what? Like, don't listen to him. Have one of these. You'll love it. She's like, what the hell? And yes, for the obvious reason of, now I get to have them all. Mm-hmm. So yeah, the other book that I brought home that I was trying to entice you with was Moyse's Elementary Geometry from an advanced standpoint. Which was my junior level, like, geometry for teachers class. So, this was when I finally realized, hey, wait a minute, I can write in my books. I mean, like, I saw it at the beginning, but it was always like, oh, that's such sacrilege, I can't do that. Freshman year, I'm like, oh no. I had a really cool pie book, and I can't figure out what happened to it. I think it got stolen. And, I had like notes all over the place in this thing to be like, you know, this is this thing. I actually had a correction that I was going to submit to the author, and and that's about when it got stolen. I was like, man, come on. Got stolen. Probably by a student. Other cool high-dimensional shapes. Not really. So, like, I don't really spend any time in any other dimensions other than 3. I mean, literally and figuratively. So, like, when I tried to do stuff with the... that would have been really cool. It was not authored by any other person. Yeah. I still need to watch that Doctor Strange movie. I still need to watch the other Spider-Man movie. Yeah, I just don't spend any time thinking about high dimensions because I'm in you know, pre-calc classes most of the time teaching, or up to Calc 2, and so I don't know, that's about it. So, yeah, my spouse and I went through the entire MCU and did all of the stuff that was current through in Endgame. So we watched everything up through that. I think we also watched one of the other movies was out. Oh, Ant-Man and the Wasp. Yeah, and then we decided that was about it. Ooh. Don't admit it. You put it in print. Mm. Yeah, I think that could show some real promise. Um, that'd be really cool. Because you'd be starting to think about like. Yeah. Yes, computers are pretty young, all in all. Yeah, we're doing like when you got your inputs. Yeah. I mean, this was far too much. I shouldn't have done this many. So here you've got your x sub I. Here you have your, hidden, I guess, so h sub I. No, j. h sub j. And then here you've got your, like, w1 or wi sub j. That'll work. That's fine. Mm-hmm. I mean, n equals 2, it's still technically a simplex. You just, it's kind of boring. Right, so got all these values here. You got all the weights. So how are you working this in higher dimensions? If you don't feel like giving it away, that's fine. Rows of boxes and bars. Boxes are like a matrix, yeah. Bars are non-linear. Okay. Boop. Really? Interesting. Surprise twist at the end. I just delete the box. Haha. So I'm not following, I guess, nonlinearity. Oh, I guess. Okay, so it's your activation function as well as just the weights individually. So do you combine both of them? Right, so you got a vector. Hey, Superbrain. And you got a vector out here. And then this is going to be like x times W. W matrix, where that's the weights, going from I to J. Rows and columns and all that. I would have to go the other way around, I guess. I'm not anymore. Do we need to do X transpose? Is that what? Yeah, X transpose. Well, yeah, but I don't know. It kind of depends. How do we actually want this? DHG of a computation graph. Okay, so W being the ith row, jth column. Gets you again numbers 1, 2, 3, 4, 5, and 6 as our inputs. And J, 1, 2, 3, 4, 5, 6 as outputs. Right, okay, so X transpose multiplied by a row is going to get you the total that's going to be in that particular output. So we're going to get jth column. So it is actually going to be horizontal rather than vertical. So I guess Superbrain, you're probably right. We could just transpose both of those things, make them vectors, and put W on the other side, and it'll be fine too. But why do I feel like I know that name? Who is... No, okay. Sorry. That last track sounded a lot like Cell Dweller. But Alex Scrindo is apparently, uh, well, obviously not the same person. Oh, unless K stands for. Nah, London-based. Okay. Never mind that. Yeah. Anyway, the last track sounded an awful lot like Cell Dweller, but that's somebody named Clayton, so he's completely different. Okay. So two curves. What's DAG? I don't think I'm familiar with that particular acronym. Okay. Right. Directed acyclic because we're literally always going in that direction. Can't cycle back around. It's when you capture it. So when you actually start using it for your own purposes. It's when you nab it. You create noise functions. Use noise functions to create random low-dimensional subspaces of very high-dimensional spaces. So you can do optimization on the very low space. Oh man. Well, keep us apprised on that, because I have absolutely no idea what any of this could possibly do. I only took the one class in neural networks. I kind of like to get back into it, but it's been so long since I've done any programming at all. I bet my institution would be perfectly happy to let me do whatever I felt like. Provided that I looped some students into it. Hmm. 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 Also true. I mean, I don't know if somebody sees promise in it. Granted, they're probably going to want to take credit at least a little bit for it, but um, if there was promise behind it, and they're like, oh, we could totally make, you know, great amount of grants and or money and or whatever off of this, then they would probably fast track that to like, yes, we will totally have some sort of grant proposal to do this thing. I know we had a student who was like, um, so she was in her second, maybe third year of getting stuff done, and ended up figuring out with her advisor at a different institution, um, ended up working out some way to get IBM's open quantum computer to basically be emulated on a standard computer, and I was like, nah, hang on a sec. And when she was able to explain all of it, I was like, okay, so maybe, I guess, and if this is true, then, you know, this technology would be worth insane amounts of money. And she was like, well, I was talking about, you know, I would, or I think it was IBM wanted her to sign something, and I was like, no, you do not sign anything until you talk with like a lawyer or somebody who's gonna actually understand this. I mean, it's probably fair. It's just, and by slow, I don't think it was like, you know, one calculation over a night. I think it was, you know, maybe slower, but not exactly. I don't know, whatever. She's not with us anymore, so she just went off on her own. We're like, all right, cool. Well, I shouldn't say off on her own. She went to the four-year institution to get her degree. And potentially some sort of, you know, research with this advisor. Definitely helps. I think my greatest problem is I don't have the time because I have to correct papers, like, you know, all night. Of course I don't, but whatever, it's fine. There's something I was gonna do. I had like 2 ideas for potential little research that I was thinking about, and then one of them I talked myself out of it. It became pretty obvious that it was a dumb idea. That was like doing long division by like trying to divide out factors from a particular number by using synthetic division. But I was like, oh wait, no, that doesn't work, because if you wanted to do 6,397 divided by, I don't know, 13, then saying 6x to the third plus 3x squared plus 9x plus 7 divided by x plus 3 is not always going to work, even if it is exactly going to be divisible. Because I was like, oh wait, right, if I have a number that has many individual factors, then we could end up, and again, this was like x equals 10. I could have a number with more than 3 factors. So I could only end up with a cubic polynomial here if I let x equal 10 and then try to do this thing. So, I mean, this one clearly is not going to work anyway because it's not divisible by 3. But anyway, yeah, I was like, oh yeah, this might be cool, and then I immediately talked myself out of it. Like, no, that's not going to work. Again, 3-digit or 4-digit numbers can have way more than 3 factors. So, oh well. Go for it, Superbrain. What you got? I can't remember what the other thing. I was thinking about something else I wanted to try with research, and just completely disappeared right out of my head. Mm-hmm. You're gonna have to remind me about the specifics, but yeah, I remember that we talked about it. So Grant from 3 Blue 1 Brown did that. He's got a video out. It's a good one. And actually, he's got 2 videos. One is his like initial video, Oh, it wasn't right. It wasn't on. Your particular one was it's mean. So, so it will give you as many grays as it possibly can at first, and maybe even switch up the word that's being selected in the background. So the first thing you'd want to do is eliminate all letters as possibilities. So you try to pick, let's go with 5 words, or 5 words that would maximize the likelihood of covering all your letters. So I feel like I would want to save Z until the very end, because there are not that many words that have Z in it. And Q. When you get a yellow letter in the third guess, you have to use it. I think the third guess is going to be the first time that you have to, absolutely have to. Well, actually, so you would want to probably guess common letters first. And something with as few vowels as possible. Because they're going to eventually throw out a vowel, and then you have to use it. So you'd want to pick some that'll eliminate all possible letters, certainly the common ones. Yeah, like you could, if it was truly absolute evil, you could intentionally, like, pick Q and Z as your last letters to throw out. And then that would severely limit the amount of Yeah, and guess you first. That would severely limit the ability of the computer to pick something that was all grays at the very beginning. So I went through and I did chalk as the first one. Light Yagamin, yes, neural networks. We were talking a little bit earlier, because Two Curbs was talking about their experience with neural networks and doing some research into potentially using higher dimensional analysis to shortcut some of the issues that come around with neural networks. So I personally have taken only one class in neural networks. It was at a master's level. Cross-listed math and science course, or math and computer science course, which my spouse and I both took at the same time. Thank you very much for the follow. Is that super loud? I did just turn it up. No, okay. Seemed alright. Alright. Killer King, welcome. Good evening. Hey, good job on the midterm. Yep. Paper's definitely the way to go. And if you have access to a library that has like Academic One file or whatever, it makes it much easier to get in there. Well, thank you very much. I appreciate the follow. I appreciate you coming on in and hanging out. If you have any questions, let me know, and try to sneak stuff in whenever I can. Yeah, I think I'm probably one of the only like math streamers who comes in like on a fairly regular basis anymore. No offense to anybody else who does stream math. But yeah, I just have the ability to say I'm going to do it on Wednesday night, and I'm always here. So, you know, except one. Yeah, sure. Drop it in, drop the whatever, drop the link in the chat, and, ooh, can we? Yeah, we can do that. Oh, I gotcha. Yeah. Machine learning papers are on archive. Nice. Yeah. That's much nicer. So, contracting Wij by Xi by Hj. So we're not going to multiply all of them. We're actually getting H sub j. Yeah, that's fine. Thanks, Killer King. So what we're doing is we're saying that this is going to be x sub I, or right, the vector multiplication is going to be x transpose times w, or you can define x as a horizontal if you want, but I always do x as vertical, make them vectors. Alright, so x of t by w is going to be equal to h sub j transpose. No, h transpose. Just getting overzealous here. It doesn't, it has no bearing. So it is whatever dimension I by j is going to be. So we have all of our inputs down this way and all of our outputs down this way. This is just connecting all of our inputs to all of our outputs. So if we eliminate this bottom one, this would eliminate the 6th column and make it a 6 by 5 matrix instead. Yeah, they were talking earlier about just shifting these around, making it easier. And I said, well, yeah, okay, but what I really want to do... But then if I did that, that would take our row of, for just input 1, and then multiply it by all of our x's, which would be all 6 x's, rather than just input 1, or the first x. So I can't just, I just can't commute x and w. It does need to be that x needs to come first. So we're multiplying all of our inputs by the input values. Now that could be w transpose, or define w the other way. But again, I want to keep it as like IJ as much as possible. Anyway, it's not super important. So as to evil Wordle, my first guess was chalk, which was all grays. My next guess was trend, which used none of the same letters, but I got 2 yellows. So it seems unlikely that it is intentionally avoiding it entirely. It seems like something else is going on behind the scenes. Because they could just as easily have done something else. Anyway. What is X as in the components? Okay, what are the components of X and the components of J? So, or H. The values that we use for X are going to be the input values for some, in this case, some sort of 6-dimensional input. So essentially what we've got here is, you know, some sort of reading that's coming out. Okay, thank you. So we're looking at taking this 6 inputs. So, I mean, super basic. We could we could do something like this. So we could take 6 inputs. Let's say it's a 2x3 grid. So if we make a 2x3 grid, this is going to have 6 inputs. This would be like x1, x2, x3, x4, x5, and x6. Or whatever. You can choose to define this however you like. Yep. No, that's fair. If you don't know calculus, you can't really do a whole lot in terms of helping. That's perfectly fine. So I'm just saying that if you wanted these 6 things to be some sort of sensor, like whatever it is, it could be like a water sensor, it could be, you know, it could be a grid in terms of which pixels are on or off, because it could just be pixels. It could be just about anything. But here, what we're going to do, in the one that we're talking about, usually it's either a 0 or a 1. It's either on or off. You plug it in, it goes into the function here. Yeah, usually binary. There's the possibility that you could have other inputs, but we don't usually like to do that sort of thing. And then all of our weights, this mess in the middle, is telling us how each of the inputs affect the outputs. So if I want to, for instance, know if I have 3... if I want to know whether I have 3 pixels touching each other, right? This would not have 6 outputs, but nonetheless, you could make some sort of... I could contrive an example better than that, but still, you could figure something out here. Our weights are going to affect the function to tell us whether all of the outputs should be on or off. It might be like, you know, Game of Life. Conway's Game of Life could tell you whether something is on or off at the end of the function. So we're going to alter our function based on something else that we've created, whatever it might be. Not many. So you've got like 1, 2, 3, 4, 5, 6, 7, 8. I think 8. Wait, no. 6. Hang on. This is awful. Alright. Concentrate on 2. 2. Alright. Okay. Yeah. It's the number of times each... the number of times each pixel is empty is really gonna... Yeah. It's just gonna be 3 factorial, so there's 6. Right? In each group of 4... one of them has to be empty. So, in order to get 3 consecutive. So, we're going to get 1, 2, 3, 4, 5, 6. Oh, that's where I got the other 2 from. Okay. So, if we're just doing L-shaped stuff, that's going to be 6. So, we have 1 here, 2 here, 3 here, 4 here, 5 here, 6 here. Oh no. 5 here, 6 here, and then straight line 7, 8. Yeah, so that one's gonna get 8. Anyway, the point over here that I was trying to make, it's a very good question. So if you tried to make something that affected our on-off... Oh no. How'd I screw up? So if it took the way in which this is all on... And it said, according to this function, we're going to turn some of them on and some of them off, and here's your output. That'd be another way to run h of j, is what is the output to this particular function? How is it going to be changed from x to h? Really, I did h as a hidden layer, so there'd be an output after it, but whatever, it's fine, we're good. Let's just skip that. Okay, so I am starting to fade pretty quickly here, so I think we're going to have to call it a night and raid out. So let's see who's available. Thank you so much for coming, and I will be here every Wednesday, unless otherwise specified. So, here we go. Head over to who is on tonight. So we got Turian's Gone Wild. Grace is funny, she's a great streamer, but I think tonight, let's see, I don't think Jason Charles Miller's still on. He probably signed off for the night. Yep, we're not doing a math raid on music. That's too bad. So I do have it, so I did open it. Thank you very much. I know. Okay, so let's go see Boss Lady B. She is playing something called Submerged. So we will do a math raid on Boss Lady B. Oh, and she has new kittens who are just freaking adorable. So, so she's been handling them and feeding them on stream in between whatever she's doing. So, yeah. It seems pretty fun. I was not paying that much attention last night. I was doing something else in the background. Anyway. So, we're going to head over to Boss Lady. Oh, let's see. Haha. Let's do this as... Goodness. I think we just had thunder. That's crazy. Alright, so we're going to do a raid call. This is the first time I've ever done a raid call. Woo! Because I now have emotes. Or an emote. So, subscribers. Go ahead with that one. And, oh. And otherwise, let's see if we can get a different one here that's also good. Trying to find the free ones for anybody else who is not a subscriber, and that is... These are a holiday, man. Yeah, we'll do that. For anybody who is not a subscriber, we'll do that one. So go ahead and copy that in, and we'll jump on over to Boss Lady B's. Thank you very much for coming, everybody. I will be back on Friday for more Final Fantasy VII Remake, because the original game was like my entire teenage years. And we will go over to come back here, next Wednesday for more math stuff. So bring friends, tell them I'm here, and we will have a good time next week. So see you later. This is Obi-Wan Pez for N Simplex Pachinko. Have a good night.